Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you Secondary 5 for opening this video. I hope in a few minutes ahead that you will pay more attention in this video, and while I explain these answers, the solution from these questions, I will also explain the concept, and then you can take notes, and maybe if you still don't understand or you still want to know more, then you can search by your own, or maybe you can text me later on. Right, Bismillah. The first one is part A, uniform circular motion. Circular motion or rotational motion, same, yeah, the same meaning. Okay, for number 1, for 20 minutes, a clock hand has covered an angle of, okay, check if for 20 minutes it's like 5, 10, 15, 20 minutes, correct? So it will be like starting from here until here, okay? Okay, I'm sorry, a moment. Okay, so if one clock, one digit, how much degree? Okay, you can check like one full rotation is 360 degree, correct? This is for 12 digits. So for one digit is like 360 degree divided 12, that is 30 degree. So for one digit is 30 degrees. So if 20 minutes, it's like 4 digits until here, right? Until here, 1, 2, 3, and 4. So 30 degree times 4 digits equals to 120 degree. So for 20 minutes equals to 120 degree. But where is the answers? Oh, you got P in here, that you know P is equals to 180 degree. So for 120 degree equals to 2P divided 3. Then you can check it, like it's equals to like 2 times 180 degree divided 3 is like how much is it? 6, and yeah, 120 degree. Okay, so the answer is 2p divided 3. Number 2, an object moves in a uniform circular motion, or in bahasa I could say like gerak melingkar beraturan. It's equal with like uniform linear motion, like uniform linear motion, meaning the speed is constant. The speed, what speed now? Now you have angular speed and rotational speed. For the uniform linear motion, the last chapter that we talked a few weeks or a few months ago, that the speed is constant, but which speed? Now you have speed, you have linear, and also you have now angular, right? Because you learn about circular motion, but for uniform linear motion we talk about linear. So the linear speed is constant, not angular, okay? But uniform circular motion, we talk about the angular speed. That is constant, okay? So so the velocity is constant. No, okay. Oh, the velocity includes direction. So the direction actually will be changed, so will not constant. The angular speed is constant. Yes, the acceleration is constant. Okay, be careful. It's like equals with like uniform linear motion. If in uniform linear motion the speed is constant, then the acceleration will be 0. So this is as well the angular acceleration also 0. What is angular acceleration? Acceleration for rotational motion, we call it angular acceleration. So the acceleration is constant, no, and the linear speed is constant, yes. Why it's constant? Because linear motion is v, that is omega times r. If omega-nya constant, then v as well constant. But which v? Speed or velocity? Don't forget. Be careful. You have speed and also you have velocity. What is the difference between those? Velocity is a value plus direction, okay? Jadi everything that include direction. But for speed is only value, only the numbering. So linear speed is constant, yes, but linear velocity not constant because it includes direction. Okay, so the answer is 2 and 4. Next, number 3. A disk of radius r rotates uniformly around a horizontal axis through its center. If point P is located on the edge of the disk, for example, I have a disk right now, and this is the P, and Q is the midpoint between the center, this is center, and P. So Q is midpoint, in the middle of the point, okay? So I will have Q in here, okay? This is Q. Then, okay, what's the answer? The angular velocity, omega, of P and Q will be same. Okay, because P and Q is one, apa ya namanya? One axle atau in bahasa satu poros gitu ya. In bahasa satu poros, then it moves, if Q moves one rotate, then P also move one rotate. So omega P will equals with omega Q. It doesn't matter how big the radius are, okay? But because it's move one rotate, Q, P also one rotate, so omega will be same. Centripetal acceleration both will be 0. Yes. Okay, correct. Because why? Because of because this is uniformly, or in bahasa beraturan. So there will be no acceleration in here. And then the angular speed P is twice than Q. Oh, yes. Okay, correct. The angular speed. Oh, I'm sorry. This is angular speed, not angular velocities. Angular velocities is angular speed plus direction. Okay, twice than Q? No, no. Angular speed is omega ya. Omega same. Omega P and omega Q will be same. But what is the twice than Q? The linear speed. Linear speed. Or we call it V. Why is that? Because V is omega times R. Velocity or speed in linear motion, it equals to angular speed times the radius. So if the linear speed of q is omega q times r, that is half of half r lah, let's say the radius ya, half radius, but v in p is omega p times r, one radius ya, yang p. Okay, so if you divided this one and this one, will be same, yes. So VQ equals to half VP. VQ is half from VP. Okay, so not the angular speed, that is twice, but linear speed. So the result is 1 and 2. Next, number 4. In half seconds, an object covers an angle of half p. Then the angular velocity of the object is, okay, number 4. You have time half seconds. Half seconds. And an object covers an angle of half p. Thetanya is half p. And the angular velocity of the object is blah 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 rad per second. Okay, if you're still not familiar with angular velocity, you can relate it between v and omega. V is as per t, okay, familiar with this one. But how about omega? Omega is also distance, but angular distance divided with time. And the angular distance is how much the angle of the object. So this is half p divided half. So the result is p with unit of radian per second. Why? Because this is in radian, yeah. So radian per second. So the answer is p. Number 5. An object moves in uniform circular motion again. This is in bahasa gerak melingkar beraturan, meaning there is no acceleration in here. Okay, at time t with 0, or in the very first beginning, the position of the object is 5 radian. Theta is 5 radian. And at position time equals to 10 seconds, the object is at position 10 radian. Or I can say like this is time 1 with theta 1, time 2 with the angular distance 2 gitu ya. And then the angular velocity of the object is the angular velocity omega. Again, if you're not familiar with omega, you can connect with linear speed. You know, linear speed is s over t. Sometimes you will find the difference of distance, delta s divided delta t. Okay, so this is actually also same with omega. That is delta theta divided delta time. Delta theta is theta 2 minus theta 1 divided time 2 minus time 1. Theta 2 is 10 minus theta 1, 5 divided 10 minus 0. So the answer is 5 divided 10, that is 0.5 radian per second. 0.5. Oh, this is point ya. Koma. Bahasa Indonesia. 5. And number 6. Number 6. You have an object with mass of 8 kilogram and moves uniformly in a circular path, moving rotational, at the speed v, not angular speed yeah, but the speed. Okay, you can check also in the unit. If the unit is meter per second, that is v, but if radian per second, that is omega. So V is 5 meter per second. And then the radius of the circle, or we say in bahasa jari-jari, is 100 centimeter. That is equals to 1 meter. Then 1 centripetal force. Okay, check centripetal force. And number 2 is centripetal acceleration. Okay. This one first. About centripetal. What is centripetal actually? Centripetal force. Centripetal force is a force that makes a body follow a curved path. So when an object moves in circular path, there is something that keeps it moving through the center. That is the centripetal force. Okay. For example, like a planet moves around the sun, there is something that keeps it there. One of those is centripetal force. So you have centripetal force that is moving through the center, but it's keep moving, yeah, it's keep moving. The centripetal force directed at right angles. Okay. It's like the usual force that mass times acceleration, right? So, but if this is centripetal force, then the acceleration also acceleration centripetal. What is acceleration centripetal? Is v square divided r. Where I got this? Okay, actually, do you still remember that the acceleration equals to velocity divided time? Okay, if velocity, you what's it? You open it, not open. Yeah, I mean, you describe more about v, that is distance over time. Okay, you have time again in here, and time in here you change it to a v divided r. Okay, where I got this, like v equals to s over t, or s in here I changed to r, then time is r over v. Okay, but because time is in below, over divided, so it changes. So v divided r is okay, s over t is v, and v divided r, so you got v square divided r. Okay, now you have v. Why I just not use v over time? Because you don't have time in here, so that's why we use v square divided r. Actually this is same, just changing the formula so you can use everything that you have. Okay, v is 5, square divided r is 1, so the centripetal acceleration is 25 meter per second square. Now you put the answer to here, that you got mass 8 kilogram, acceleration centripetal is 25, so the result is 200 Newton. So the 200 Newton correct, 25 also correct. And for the time, playback time is meaning the one time for one rotation. Okay, for playback time, meaning one time for one rotation, or we can call it period, or simbolnya T. Okay, how about T for the time or the period? The period is, for period, we can find period from omega. You know, the omega or the angular speed is theta divided time, right? Okay, and theta in here is 360 degree. That's why we also usually 2p. We also usually use 2p divided time in here. But time in here right now, we can use period as well, meaning the time. Time for one rotation. That's actually the same. So you have omega, another formula than theta divided time. Theta is the angular distance, yeah. Omega equals to 2p divided time, time of period. So period. How much period? Period equals to 2p divided omega. How much is omega? Omega is, do you have omega now? No, you don't have omega. You find omega first. Omega you can find from V divided R. V is 5 and R is 1, so the answer is 5 radian per second. So you have 5 in here, so the result is 0.4 p second. 0.4 p seconds. This is also correct. And the angular speed is omega 5 radian per second. This is also correct. So the correct statements are all true. Number 7. A particle undergoes uniform circular motion with period. Nah, you are now familiar with period. Okay, period you have t p second. Okay, again, period is one time. I'm sorry. Period is time that you need to one full rotation. That is period. Okay. And you have path radius, or in bahasa is jari-jari, to centimeter change to meter first because you will use meters at the end. 2 times 10 minus 2 meters. And so the length of the circle traveled by the particle in 2 minutes, you have time 2 minutes is 60 seconds. The length of the circle is s actually. How you find this? If if v, the linear speed equals to omega times r, v is linear speed equals to angular speed times r, then you will also have as, this is like the connection between linear and rotational. V familiar with s as the distance. For omega you have theta as the distance and r as well. So this is the connection between s and theta, between distance in linear and between linear and linear distance and angular distance. So now the question is how you find the theta in here, the angular distance. Again, you can find using omega. Omega is theta divided with time, right? And how about the theta now? You still don't have this one yet, theta. Okay, let's use another one. What? Okay, omega. You have omega 2p divided time. 2p divided period. Big T. Now, I will give you one concept in here. Period is opposite with frequency. If period is time that you need time for one rotation, then frequency is how many times for each time. How many times the object moving for each time. So frequency is n divided time. N is the number how many times gitu ya. And for period is time divided n. Okay. So omega in here you have 2p, you got period now. So this is p divided, then you got 2 radian per second. Then you can find theta now. Theta is omega times t. Omega is 2 and time you have 60 seconds, so the result is 120 what? 120 radian. So you got S is 120 times R2 times 10 minus 2, then you got 24, 10 minus 1 equals to 2.4 meters. 2.4. Wow. There is no answer to, oh yeah. Am I doing something wrong in here? Oh, this one. I'm sorry. 2 minutes equals to 120 seconds. So this is 120. The result is 240. This is not 240, yeah. So the answer is 4.8. 48 times 10 minus 1 equals to 4.8. This is point, yeah. Point. So this is 4.8. Okay, now number 8. A particle undergoes circular motion with a constant speed of 4 meter per second. 4 meter per second. Meter per second is linear speed. And centripetal acceleration, you have a centripetal acceleration is 20 meter per second square. So the number of rotation for every minute 60 seconds, yeah. How much? How many times? Let's think about this first. We can start to find n, yeah. The one that I can think is omega. Omega equals to 2p divided period. Now you have this formula, yeah. Take a notes. And you don't have omega in here. Okay, you can start from this one, linear speed and acceleration centripetal. If you have acceleration centripetal as v squared divided r, that I already explained before, a few numbers before, and v is equals to omega times r, okay, square divided r, so you got omega square times r. This is also this is also centripetal acceleration. Oh, sorry. You can start using this one. You can use this one, yeah. Okay. repeat again. So you have angular centripetal acceleration, sorry, is 20. V is 4 square divided R, okay? So you have R is 16 divided 20. So the result is 16 divided 20 meter. Okay, what else? Okay, because you need using angular speed, so we can start from here, I think. Oh yeah, centripetal acceleration equals to also omega square times r. And centripetal acceleration is 20. Omega now you don't have, and r you know now you have is 16 divided 20. It's changing place. Omega square equals to 400 divided 16. So omega is root of 400 divided 16. Root of 400 is 20. Root of 16 is 4. So the result is 5 radian per second. What will we do with angular speed? Coming from here, now okay, because I already said that period is opposite with frequency, or frequency is opposite with period. So I can write in here 2p times f. Okay, and frequency is how many times divided time. How many circulations, how many rotations for each time, that is frequency. So now we can start from here that omega is 5, 2p, and is the one that we are looking for, and for time is 60. You changing place here, so meaning 2p and equals to 60 times 5, 300, and equals to 300 divided 2p, meaning, okay, you can try in using calculators. You can try using calculators. It equals to 300 divided 2, because in multiple choice no p in here, then you need to put the value of p, that is 3.14 or 22 per 7. That's okay. Then you will got the answer around 47.7, or you can round up to 48 times. So the result is 48 times this one. Okay. Now, oh yeah, of course, if you're still confused with this one, I want you to calculate by your own, or you can put this calculation to your book. Then you can try to understand more. Of course, not only listening, not only watching, but also you need to do it by yourself. That's the process of learning. And bahasa, process of learning, tidak hanya melihat, tidak hanya mendengar, tapi juga harus melakukan. So, if you want to complete 100% understand, then you need to do it by your own. Not only watching, but also calculating. Now, number 9. This is about frequency and period, and I already explained before with for you, that is period is time for each rotation. Time for each rotation, but for frequency is how many times for its rotation. Gitu ya. In bahasa, periode itu adalah waktu dibagi dengan berapa jumlah putarannya. Kalau frekuensi, jumlah putarannya dibagi dengan waktu. Jadi dia opposite, kebalikan. Oke ya. Now, number 9. An object moves circular motion. You have radius now. You have radius 4 meter. And angular displacement 1/6 turn in 2 seconds. Apa itu ya? What does it mean? One per six in 2 seconds. Can you imagine this one? 1/6 turn. If this is one turn, 1/6 itu you divided this to 6 part. 1, 2, 3, 4, 5, 6 gitu kan ya. 1/6 is like here. This is 1/6. 1/6 turn in 2 seconds. So how much is the omega? Omega is theta divided time. You have 1/6 divided 2. So you got 1/12 radian. Okay, let's just continue first. You are asking to find period. T is, okay, can you use time divided n? Maybe yes. Time for 2 seconds. This is 1/6. Oh yeah, so you got 12 seconds. Oh yeah, you got the answer right now. 12 seconds. You don't need to use this one, yeah? But just in case you need it, and you can find this. But you can only use this formula. Number 10. You have time 1 minute. Time 1 minute equals to 60 seconds and does 120 rotations. The frequency of the particle is n divided time, and is 120 divided 60. The result is 2 hertz. The unit of frequency is hertz. Number 11. The ratio between frequency of hour, minute, and seconds. Wow. Okay, you know, omega is 2p divided period ya. Why we use period, not frequency? Because we talk about time, so we use period. And period for hour is 12 hour a day, meaning 43,200 second. You can calculate it using calculators. And period for minute is 1 hour is 60 minutes. So for time is 3,600 second, and for time for second equals to 1 second. 1 minute equals to 60 second. Now this is the comparison. Omega, okay, rotation for clock will move together. So omega hour equals with omega minute equals with omega second. So 2p divided time hour, 2p divided period of minute, 2p divided period of second. So 1 per 4 3 200 equals to 1 per 3 600 equals to 1 per 60. Kita sederhanakan ya, let's simplify. Times 4 3 200. So you got this one is equals to 1. This one is 12. And this one 720. So this is the comparison. 1, 12, and 720. Okay, that's all for this video. Until here, I will continue the next numbers in the second video. Please try to understand more about this one. But if you have another answers, not using mine, not using this way, or you have others way, other solution that is much simple, that is really good. You can use your own understanding to answer this solution. But the one that I want to explain in this video is the concepts of circular motions. So that's why I said a few meetings ago that if you answer this one questions in this one paper with 25 questions, yeah, or 20 questions, I already include all of the concept in here. So yeah, this is all of the concept more or less. I will make a second video to answer number 12 until 20, yeah, if I'm not mistaken. Yeah, and all of the concept already here. Again, you must not only hearing, not only watching, but also writing. Jadi teman-teman harus mencatat, mau gak mau. Nah, I didn't write the information like v equals to linear speed, omega is angular speed, period is t. You will write it with your own. Oke, kalian tuliskan keterangannya sendiri dengan memperhatikan video ini. Oke. Enjoy watching this video. Thank you so much. See you in the next video. Thank you. Assalamualaikum warahmatullahi wabarakatuh.